In this set of notes, we're going to learn how to graph a line using a different method. Prior to today, we've been graphing lines either in Desmos graphing calculator by making an input-output table or using slope-intercept form, y equals mx plus b, where we started by graphing the y-intercept on the y-axis and then rising and running according to the slope. Today we're going to learn a different method called x and y-intercepts. So if you remember from slope-intercept form, the b value is our y-intercept, and that was the point on the line where the line crosses the y-axis. There's also an x-intercept, which is going to be the point on the line where it crosses the x-axis. So if you think about these words, intercepts kind of sound like intersecting, and so x-intercept would be intersecting the x-axis, and the y-intercept would be intersecting the y-axis. So if I look at my first example, I've got my line, and I have it crossing the y-axis. Here, I'm going to put a square, because this says to put a square around the y-intercept, and then it also is crossing the x-axis, so I'm going to put a circle. And now I'm going to write the coordinates of each of these 2 points as an ordered pair. So it's important to remember that your ordered pair is a roadmap of how to get to this point. So if I'm at the origin and I want my reader to get here, I need them to go right 3 and up 0. So this, as an ordered pair, would be 3, 0. For them to get to this point up here where the line crosses the y-axis, I'd want them to go over 0 and up 3, and so as an ordered pair, this would be 0, 3. It's just coincidence that they both happen to have 3. This line happens to have similar intercepts. What I'd like you to do right now is to pause the video, put a square around each y-intercept for examples 2, 3, and 4, put a circle around each x-intercept, and then write the coordinates on the line provided as ordered pairs. Pause the video, press play when you're ready to check your answers. So for example 2, the line crosses the x-axis at -3, 0, because it's negative because it's to the left, and it crosses the y-axis at 0, 2. For example 3, it crosses the x-axis at 3, 0, and crosses the y-axis at 0, -4. For example 4, it crosses the x-axis. This looks like about -1/2, 0. We'll talk more later about how to be precise, but for right now that's a good estimate. And it crosses the y-axis at 0, -1. One thing to be aware of, one common mistake we see people make is, for example, let's say on example 3, they take the 2 numbers for the x-intercept and the y-intercept and they put them together. So they take the x-intercept of 3 and the y-intercept of -4, and they put those together. But remember, as a roadmap, that would tell the reader to go 3 to the right and 4 down, which would land here. And so that's one single point that's not intersecting either axis. It's going to be important to realize that I've got 2 separate points, so I need 2 ordered pairs, and each of those is going to be paired with a 0. We'll investigate more of that in 1 second. So one of the things that we just noticed is that in order for a line to cross the x-axis, it needs to be touching the x-axis, which means it can't be at all up or down below it. So the only number that would allow this to happen is if the y-coordinate is 0. So anytime we find an x-intercept, the y number is going to be 0. Anytime we find a y-intercept, it can't be left or right at all, and the only way for that to happen is for the x-coordinate to be 0. So when we find intercepts, we're doing 2 separate problems, one where x is 0 to find my y-intercept, and one where y is 0 to find my x-intercept. We're going to use this intercept table. You'll see this throughout, and at the start we've had a place for you to show some work. So I've got my equation, 2x plus 4y equals 12. I could isolate y and use slope-intercept form, but because it's written in standard form, it's going to make more sense and be more efficient to graph it using x and y intercepts. So I'm going to start by rewriting my equation. And so on this side, I'm going to find my x-intercept. And I'm just following my arrows here. So this arrow is coming from the row where y equals 0. I know if y equals 0, I'm finding my x-intercept. So I'm going to take my equation, 2x plus 4y, but I'm going to swap out when I get to y, I'm going to replace it with 0. Then I'm going to do that math. 4 times 0 is 0. Anything plus 0 is itself. That won't change it. So 2x plus 0 is 2x. And then I'm going to divide both sides by 2. That will give me an x value of 6. So what this tells me is that when I replaced y with 0 in this equation, I got an x value of 6. I'm going to go over to my graph and graph this ordered pair, 6, 0. So that would mean to go 6 to the right and up 0. Now I'm going to do the same thing, but I'm going to do it for my y-intercept, which means that I'm changing x to 0. And so in my equation, 2 times, I'm going to swap out x and replace it with 0. So 2 times 0 plus 4 times y equals 12. I'm doing that same equation that I see up here. 2 times 0 is 0. 0 plus 4y is just 4y. And then to get y by itself, I divide both sides by 4. And I get a solution of y equals 3. So that means that when I changed x to 0 in the equation, I got a y value of 3. So I'm going to come over here and I'm going to graph that ordered pair 0, 3. Now I'm ready to connect, so I want to connect these 2 points with a straight line. One thing that's going to be important to do here is not just to connect red to blue, but to connect a continuous full line, because I want to show that this line extends beyond these 2 points. The intercepts just happen to be 2 of the points that are on my line. So at this point, I would take out a ruler, I would connect those 2 points, and I'd put arrows on both ends. Because remember, a line is infinite points contained on it. Let's do one more of these together. So down here on example 6, I'm going to find my x-intercept on this side. That means I'm going to be swapping out 0 for y, or taking out y and putting 0 in its place. So 3x plus 2 times 0 equals 6. 3x plus 0 equals 6, which would get me 3x equals 6. Divide by 3, and so that's going to get me x equals 2. I can graph that. Then I'm going to do a similar process for my y-intercept, but this time I'm going to change x to 0. So I'm going to do 3 times 0 plus 2y equals 6, which would be 0 plus 2y equals 6. 2y equals 6, then divide by 2, which gets me y equals 3. So I'm always going to have, when I'm graphing using x and y intercepts, I'm always going to have one point that's on the y-axis and one point that's on the x-axis. So 2 separate points, one on each axis. Then I'm going to connect these 2 as best I can with a line. So I'm going to take out a ruler, and then I'm going to put arrows on each end of my line. So at this point, I'd like you to try examples 7 and 8. So there's a little space on this side to do the work for the x-intercept, a little space on this side to do the work for the y-intercept, and you've got your intercept tables for each. One thing to pay attention to on these 2 examples is that there are negative signs that were not contained in the previous 2. So just be sure to pay attention to your signs. Pause the video to get started, press play when you're ready to check your answers. So on example 7, to find my x-intercept, I changed y to 0. This ended up becoming 4x equals 10, and then I divided both sides by 4. 10 wasn't exactly divisible by 4, but you could reduce it to 5 over 2, which actually became 2.5. So this is an example where I think it makes a little more sense to think of it as a mixed number. So to graph 2 and 1/2, 0, I just went over 2.5. For my y-intercept, I changed x to 0. One key thing here is to remember that this negative sign in front of the 2 is going to continue down. So when it's time to divide, I'm going to divide by -2 to get me y equals -5. So my y-intercept is down 5, or at -5. So if you had a positive 5 for your y-intercept, just go back and see if you had this negative sign here. And then we connect it all the way through. Remember not just to connect blue to red, but to go all the way through to have a nice full line. On example 8, for the x-intercept, we changed y to 0. Eventually we're going to divide by -3. Negative divided by negative is positive. So my x-intercept was 5, 0. My y-intercept, I changed x to 0, and so eventually we divided by 5. Negative divided by positive was negative, for a y-intercept of -3, and so this is my line here. Go ahead and give examples 9 and 10 a try. We'll come back and talk about 11 and 12 in a minute. Same work, you're going to do your x-intercept work over here, your y-intercept work over here. You're going to graph your 2 ordered pairs. Remember, you should have one on the x-axis, one on the y-axis when you're done, and then you're going to connect with a full line. Pay attention to your signs on example 10. Pause the video, press play when you're ready to check your answers. So on example 9, if I change y to 0, this just simplifies down to x equals 4, because there's nothing you need to do to isolate x. 4, 0. If I change x to 0, I'm going to divide by 2 to get a y-intercept of 2, so 0, 2. On number 10, if I replace y with 0, I get 3x equals 12, and then divide by 3 to get an x value of 4 for an x-intercept of 4, 0. And on the y-intercept, if I change x to 0, don't forget to put this negative sign in front. That'll come down. I'm going to divide by -4 to get -3 for my y-intercept. Don't forget to draw nice full lines with arrows on each end. So let's take a look at examples 11 and 12. These are a little bit different because they're not written in standard form. They're actually written in slope-intercept form. So if you were given these examples in the real world, you might decide to use slope-intercept form to graph them. But it's important to remember that right now we're being asked to use x and y intercepts. So for my x-intercept, remember that we know that in the equation, y gets changed to 0. So we're going to do that. Oops, I made that y also. So I just took my y and I changed it to 0. Now I'm just going to get x by itself by adding 4 to both sides. And so I get an x value of 4. So right here, when I changed y to 0, because that's what I do when I'm finding an x-intercept, I got an x value of 4. And then I would go and graph that. For my y-intercept, I would do the same thing, but I'm going to change x to 0. So I've got y equals, and then I would make it 0 minus 4. That's going to give me a y value of -4. And then I've got my y-intercept. Then I can connect those with my line. So following that similar idea of replacing x with 0, y with 0, I want you to try example 12. You have space for both your x and your y-intercepts. Pause the video, press play when you're ready to check your answers. So on example 12, if I replace x with 0 for my y-intercept, I get 2 times 0, which is 0, for a y value of 6. So my y-intercept is 0, 6. For my x-intercept, if I change y to 0, to get x by itself, I first need to subtract 6 from both sides, and then divide by 2, which is going to get me an x value of -3. One interesting thing to notice about both examples 11 and 12, since they're already in slope-intercept form, we would know that this number, -4, and this number, +6, are my y-intercepts right off the bat. And I can actually see that here. Also, I can see that both lines have an increasing slope. So just by using my knowledge of slope-intercept form, even though I'm not graphing using that method, I can kind of check my work as I go.